Okay, so I think it's time. So welcome to the cafe, October Cafe, Indoor Ag Science Cafe. I'm Cary Kubota, the Ohio State University. So as usual, let me start with a few slides to navigate you for the system, particularly if you are new in this cafe platform. We are using Zoom, and then microphone is under your control, but please mute your microphone when you are not using. Make sure you are not transmitting your background noise and things like that. And then you are welcome to turn on your video. That's fine with us. I like to make it very interactive forum. So always nice to see your face, but you can not to do so. That's totally up to you. So upcoming series of cafe. So today the topical speaker is Cary Mitchell, Dr. Cary Mitchell from Purdue University. And then next month, I'm going to give a short presentation. My topic is going to be the basics of plant response to the temperatures. So it's going to be probably more educational type of cafe on that. And then December 3rd, so that's December Cafe, we will be trying out something new. And this is called Indoor Ag Science, actually not inquiries, queries. So that's my title. And then we will have all the experts from the SCRI newly funded Optimia project team participating. And basically the idea is answering to your questions, any questions. And then January, I'm still recruiting speaker. And in February, uh, Dr. Paul Fisher from University of Florida is going to talk about, I think he's going to talk about biofilm and water management or irrigation management. So that's interesting topic. So just let me explain what is the new series we are launching. So we are doing within this Indoor Ag Science Cafe, and then we will do the first Indoor Ag Science queries. And then basically, you're going to submit your question anytime. So this site is going to be open all the time. When you come up with question, just submit your question. And then we will select the questions, screen the questions, and then do that in a series of queries. So the first one is going to be December the 3rd, and then we will pick up the questions and answer those. You can disclose your name or not, that's up to you. You can totally anonymous person in a space. So that's what we are doing. All right. Then move on. So let's have Dr. Cary Mitchell from Purdue University presenting early history of indoor plant agriculture and associated technology development. So we're going to learn the history of that.
Okay. So I'm going to attempt to share screen here.
Mm-hmm. I see your desktop. Yep.
Can you see that?
Yes.
Okay. Well, good morning, everyone. Thanks very much for logging in and for coming. When I agreed to do this presentation on history, I didn't realize what I was biting off, because we call it a very young, nascent industry, and yet there's already an overwhelming amount of history out there. So I think we're going to have to do this in sessions. And today, I'm going to have to limit my comments to the early history of indoor agriculture and associated technology development. I don't know all details about every enterprise, and I am not aware of all indoor ag enterprises. And so for that reason, I invite those of you who do have that knowledge and information to share it with me. And I will attempt to serve as a clearinghouse for historical facts and events relating to indoor agriculture. So consider this presentation as a living document that can evolve over time. Starting off, I would like to take a long view of organized agriculture to give a perspective of the time scale that is involved. We have been at open field agriculture for at least 12,000 years now, and believe it or not, greenhouses in one form or another have been in existence for almost 2,000 years. The basic principles of greenhouse technology have not changed substantially over time. Today's greenhouses have a lot of bells and whistles that give them the moniker semi-controlled environment. Within the overall scheme of farming, fully controlled environment agriculture, or CEA, has been around for only about 50 years or so. And the degree of environmental control varies considerably from case to case. The next phase will involve stepping off Earth, providing at first food supplements and eventually balanced vegetarian diets for closed-loop bioregenerative life support at future destinations. So that's yet to come. Even though growth chamber and phytotron research with plants has been going on since the 1950s, we think that one of the first CEA enterprises was genoponics, a synthesis of the words General Electric and hydroponics that opened in Syracuse, New York in 1973. Genoponics initially had funding from the Department of Defense to grow fresh vegetables on nuclear submarines that would stay submerged from 6 months to a year at a time. This was great for the crew, but DoD soon dropped genoponics funding in favor of gaining back space to store torpedoes that trumped space to grow fresh vegetables. After that, GE self-funded genoponics for a while, and they also had some short-term sponsors. Genoponics used HPS lamps, recirculating hydroponics, carbon dioxide control, and they had air conditioning to grow tomatoes, lettuce, and cucumbers indoors. We're not quite sure whether they had oversized growth chambers or rooms that they configured, but still looking into that. They were able to achieve 5-fold higher yield rates than in the field and high market values, but they found, at least for tomatoes, that they could only be profitable if electricity cost less than 1.5 cents per kilowatt hour. I believe that genoponics sold some of their produce commercially for a while. Control Data Corporation purchased them in 1980 and tried to make a go of it, but rising electricity prices led to genoponics finally shutting down for good in 1984. I know a bit more about the next indoor CEA enterprise, Phytofarms of America, because I visited there more than once. Phytofarms initially was a General Mills development in 1978, but the big company quickly got out when they realized that the technology was not yet there for near-term significant profit margins. Developer Noel Davis bought Phytofarms back from General Mills, and Noel made a go of it until the early 1990s, when a number of factors made him also close his doors. Phytofarms had a number of innovations worth mentioning. It was warehouse-based. It used CO2 injection and was strategically located in DeKalb, Illinois, to deliver to the Chicago, Milwaukee produce markets, including gourmet restaurants, at a time when hydroponic vegetables were still quite novel. They practiced assembly line production of plants, with plants slowly moving along conveyor-like benches as they grew in size. This was done on 2 different floors of the building, so it already was vertical in that sense. Innovations included water-cooled 1,000-watt HID lamps that allowed lamps to be placed about 4 feet above the crop stand. Waste heat was exchanged outside, even in the winter. Another innovation was self-spacing plants that kept up with growth rate as they moved along the bench from the planting end to the harvest end. Troughs with recirculating nutrient solution were placed at right angles across worm gears that spaced the plants out as they got bigger. This is a picture that I took from the harvest end, showing that the moving canopies still remained pretty closed, so that photons were not being wasted on empty spaces between plants. You also see reflective foil sidewall sheets that would blow in the wind, so air movement occurred across there. You see fans mixing air with CO2 coming down from that tube above, and alternating HPS and metal halide lamps. I'm not sure with the luminaires they have whether they had effective spectral blending, but they did get blue biased and orange biased light maybe at different times as they moved slowly along the bench. Phytofarms burned more than a megawatt of electricity per hour, which ultimately contributed to their demise as the price of even off-peak electricity from Commonwealth Edison rose over time. It was a number of factors, and Noel Davis was going to move up to Minnesota and try to open Phytofarms 2 on an Indian reservation where he could get hydroelectric power free, but I don't think that plan ever came to fruition. But these guys were very innovative and made a go of it for about at least 11 years. Here is a yield comparison summary of phytofarms and genoponics with greenhouse and field production. This is from a NASA technical memorandum by Maynard Bates and David Bubenheim. I don't have the year yet on this one, looking for it. Year-round crop production indoors contributed a lot to the annual relative advantage of the indoor over outdoor production, and degrees of control indoors merely widened that advantage. Notice that genoponics grew fruiting vegetables indoors as well as leafy greens, whereas phytofarms limited themselves to greens and herbs. While genoponics and phytofarms were in operation in the USA, Jan Lestraden in the Netherlands pioneered the concept of stacked layers within a factory to grow crops. And this was in 1984. He evidently had been a successful indoor mushroom grower before that, and he was already stacking shelves in his factory for mushrooms. So he tried expanding into leafy and fruiting vegetables and some ornamentals. He tried different lamps for lighting, and he found that among those that were available to him, Jan found that neon lights worked best for his application. From what I've been able to read, crops appeared to be contained in large closed cells that were periodically ventilated through air filters. Apparently, that was all about disease control with the mix of different crops that he was trying to grow simultaneously. I don't know how long this operation lasted, but from the media reports I was able to read, local CEA critics just couldn't wait for it to fail. They were very critical of this. Now we move to Japan, where the term plant factory with artificial lighting, or PFAL, became popularized. A lot of background growth chamber research in support of PFAL development was conducted starting in the 1970s. And by the late 1980s, diverse operations went commercial. TS Farm, which utilizes aeroponics and A-frame design, started up around 1989-90, somewhere in there, and apparently still is in operation today, which is its claim to fame. It might be one of the, if not the longest continually operating indoor farms. PFALs started out with HPS lighting. Then they went, believe it or not, to fluorescent lights when those lamp types improved in output in the late 90s. But then they started converting over to LEDs by about 2005. And due to the high population density in Japan, the Japanese thought that use of vertical tiers was a no-brainer. And they are generally credited with the stacking concept and its relative productivity advantage, although the Dutch were already doing that as well. A number of PFAL enterprises survive long-term in Japan, and we think among the reasons for that has to do with government subsidy and involvement of academia in the design and testing of systems and working together with industry in their vertical farming or plant factory associations. And a key person in that was Toyoki Kozai from Chiba University. He's been a leader in organization of the PFAL industry in Japan and has become known in Japan as the father of the plant factory. Kozai also has really pushed multi-authored books from multiple countries on this topic. And this is a real contribution to the field. The first edition, co-organized by Genwa Nu in the USA, came out in 2014. And the second edition of that volume is scheduled to come out yet this year. Kozai also headed up this multi-author reference book published in 2016 on LED lighting for urban agriculture, and that is has been co-organized by our own Eric Runkle. In summary, countries where indoor ag is under development include, of course, this one, where the players typically are private with investors and large. Japan, which probably has the most, and has been government subsidized. Taiwan with some subsidized R&D. Korea exporting technology. China importing technology, getting ready to take over their local CEA industry. The UK and EU are interesting. There is interest there and some indoor ag development. But what they are bucking is a very well-established greenhouse industry. I did not get Canada on this slide, sorry, but they are a leader in CEA technology development, especially for seasonal climates, and there's a lot of interest there. One thing unique about the indoor ag industry, it seems to be best for local production, not for expanding into global markets so much, at least not with the highly perishable vegetables. Now I would like to expand into technology development that has supported the indoor ag industry, and I would like to start with NASA's biomass production chamber, which existed between 1987 and 2000. It was constructed at the Kennedy Space Center in Florida from a high altitude simulation chamber that previously had been used to test Mercury capsules for space vacuum tolerance. In converting it to a plant growth chamber that could operate in a closed configuration for research purposes, it actually was operated under slight positive pressure, just the opposite for which it was originally designed. The BPC was outfitted with large chillers and blowers, elaborate hydroponic controls, and a mission control in true over-engineered NASA style or tradition. Crops were grown hydroponically around the inside periphery of the BPC. And the Waldman's green leaf lettuce you see here in the background that looks so yellow is actually because it's under HPS lamps. Under a broader band light in the foreground, it looks darker green. The HPS lamps mounted above the dwarf wheat in this image are enclosed by a light cap, separately ventilated light cap to isolate and prevent excess lamp heat from overheating the wheat crop and the crew below. Looking up at 4 different levels of wheat growing in the BPC, NASA today, somewhat wistfully, likes to refer to the BPC as its vertical farm, which was among the earliest ones. It ceased to exist before the explosion of indoor agriculture as we know it began. NASA does not keep hardware around. When they are done with it, they dismantle things. So there's no museums. I wish there were. So one of the triggers for that explosion of the indoor ag industry was the application of, one of the triggers for the explosion was the application of light emitting diodes, or LEDs, for plant growth. And because of the high energy requirements for plant growth lighting at high light levels, because of that, NASA sponsored the first research and development to test the responses of plants to light from LEDs. And the first publication came out in 1992, and some of the people involved in that research were also involved with the phytofarms operation that was put out of business by paying electricity for HID lighting. In an effort to help cut down energy costs further using LEDs. The concept of intra-canopy lighting and sequentially switching on LED light engines from the bottom up along a vertical array followed from that. And the first air-cooled lightsicles became available for testing in growth chambers in 2003. A number of people who had been doing early work with LEDs in plants got together to put on a workshop on LEDs in horticulture at ASHS in 2007. And in the following year, the proceedings of that workshop was published in Hort Science. And that proceedings made that issue one of the most highly cited issues in ASHS history. And this article in that issue has become one of the most highly cited articles in Hort Science history, which reflects, I think, the public degree of interest in LEDs for plant growth lighting. And it's still being cited quite a lot today. Shortly after that, Dixon Despommier from Columbia University published a book, The Vertical Farm, which was attributed to an undergraduate classroom exercise. I don't know what the class was, but Despommier was a professor of microbiology and public health at Columbia who received some credit for the VF vertical farming concept, which of course far preceded this book. Even if he and his discovery, if his class were unaware, blissfully unaware of all of the preceding history, their independent discovery of vertical agriculture, I think it does say something about the logic of vertical stacking in indoor ag. The best thing about Despommier's book is that it brought public awareness of the VF concept that up until then had not come in any significant way from the academic community, and that was a contribution. We academics are very good at talking to each other and not always to the public. I think it was the utopian pie-in-the-sky view of inner-city vertical farming that set off some ag engineers and controlled environment experts, especially about the naivety of where the energy would have to come from for such grandiose enterprises. Nevertheless, as I said, there is a contribution there as well as a challenge, and that is to make some form of vertical farming profitable and sustainable. Regarding space farming, NASA launched 2 veggie plant growth units to the International Space Station in 2014. And since then, astronauts have been growing various vegetables for consumption and research on a more or less continuing basis. This sort of application is why NASA started sponsoring research with LEDs and plants in the first place. And a major spin-off or Earth application has been the enabling of the vertical farming industry as we know it, that is taking place. Meanwhile, same year, back at the ranch, the combination of close canopy lighting and targeted lighting was demonstrating that very significant energy savings could be realized growing crops of leafy greens. That article, which was published in a space journal that was read worldwide, has had a very positive readership reaction to leveraging those unique properties of LEDs for energy savings in indoor ag. Right after that, the multi-institutional research group that was awarded the First SCRI grant to develop LED lighting technologies and practices for sustainable specialty crop production. Published an article entitled Light Emitting Diodes in Horticulture, and this was in Jules Janik's Horticultural Reviews. A lot of good literature about all aspects of LEDs and plants, and is discussed and cited in that 86-page review article. It's 4 years old already, but not too obsolete yet, but there's a lot of literature, of course, that has come out since then. The technologies that have come together to enable CEA in general and indoor agriculture in particular include soilless culture, which started in the 1930s, the advent of plastics, which made hydroponics feasible in the 40s, environmental control systems evolving out of the growth chamber phytotron research era that started in the 1950s, computerization and automation of those controls starting in the 80s, continuing, and most recently the LED era starting in the early 90s, which has kickstarted the industry to where it is now. So all of this history and technology development has come together to define the characteristics of a vertical farm as we know it today. An insulated warehouse, vertical tiers of grow racks, today with LEDs, HVAC for climate control, CO2 injection and control, especially for large warehouses filled with vegetation. Typically, recirculating hydroponics or aeroponics, and computer-based environmental control. Currently, what I see is going on is ongoing advancements in LED technology and its applications, decreasing capital costs, although they still are high, and grants to enable expansion into a variety of capabilities and for a variety of purposes. I have seen the commercial industry move from a blend of monochromatic LEDs a few years ago to a mix of mostly broadband whites plus a few red LEDs, or just warm white LEDs. Lettuce likes that. I don't know about all leafy greens and herbs, arrays that are dimmable by channel with multiple channels available might give flexibility for species or cultivar differences, but will cost more. Perhaps growers will specialize in crops they can grow most efficiently with the lighting fixtures they have available right now, and will expand into fancier arrays once their ship comes in. So I would be glad to serve as a repository for historical information, not only about early indoor ag, but about current indoor ag companies as well. And perhaps in a year or so, we can update this early history with more information, at least within this country. I'm not quite sure how to stay current about the existing international situation, but I will be very happy to receive information from anyone on this topic. So I thank you for your time this morning, and I'm sure I have left out things, and I certainly welcome receiving additional information from you, and I'll try to fold it into this this evolving history. So with that, Cary, I'll stop sharing, I think.
Thank you very much.